Hello dear students, this is Jayant Mane from Phenolics Academy Ratnagiri. This is 8th lecture of Retardation control, and today I am going to tell you about calculation of moment of inertia using retardation test. So this test I think you have already studied while you were in the second year. So I'll just briefly tell you about this test. Now, as we know that previously we have already derived the fundamental torque equation, which is T minus TL equal to J d omega m by dt. So J term is there in that torque equation, and we know that J d omega m by dt is the dynamic torque which plays vital role in the dynamic conditions or dynamics of the drive. Means how fast the drive can be reversed or stopped, and or speed can be changed. All that depends upon J, as well as d omega m by dt means rate of change of speed. So J is part of dynamic torque. It is very important thing to calculate. We must know J to know the performance of the drive. Now traditionally, as written here, moment of inertia can be calculated if dimensions and weights of various parts of the drive and loads is known. So this is a traditional method wherein all parts, their dimensions you know, their areas you know, their weights you know, but practically the machine is made up of complex materials. It is not a single body or a single cylinder made up of a single material, isn't it? Because core is of different material, winding is of different material, then there is a insulation inside the machine and all that. So every part is a bit complex, so it's very difficult to calculate inertia using this method, given your dimension, weights are known and all that. Instead of that, experimentally using retardation test, we can determine the moment of inertia. It is obviously some approximate value, but still the results will be very good of this test. Now, as you see here, the curve is plotted, which is change in the speed omega m with respect to time. So and there is some initial speed you can see, and this is the curve. So it is a speed with respect to time. Now how to plot this curve? To plot this curve, we have to run a DC motor beyond no load speed. So how to do that? So obviously, for doing this experiment, the drive for which we want to calculate the inertia, means motor along with its load and all that. So we have to run the motor beyond no load speed. So for that, obviously, if there is some motor, suppose there is a DC motor, then there has to be some starter resistance and then connected to supply, and there is also field part. Suppose it is shunt motor, then you can insert some resistance into the field winding, which is variable resistor. Starter is also variable resistor. This is a starter, RST, and this is field resistor. So this motor can be run, start with the help of starter, then by varying the field rheostat, flux can be reduced and the speed may go beyond no load speed. Now this is the starting point of the test. So we have to note down the initial speed of this motor, and then we have to measure the input power to the drive, so that is P. And then just we have to cut off the motor from the supply, and then just keep connected the tachometer to the shaft and note down the readings. So for as the speed is continuously varying and you have to take the readings, you can do one trick. You can just do some video shooting of the tachometer, then you can just pause the video at different points and you will get some of the points on this curve. So not at regular intervals, it could be some different intervals. Get the points and just join them to get the curve. So this is how you get this curve. Okay, then how we can calculate the inertia now. So P is equal to rate of change of kinetic energy. So whatever was the P initially being supplied to the drive at the start of the test, so all of that was there in the kinetic energy. So P is equal to kinetic energy, that is d by dt of 1/2 j omega m square, and when we take derivative it is half 2 omega m j d omega m by dt. So after simplifying we get this j omega m into d omega m by dt, where j is unknown, omega m, so here it is written omega m 0. So this point you will get from the curve. So we have to draw a tangent, I will show you, and this is the slope at that point, d omega m, that is difference or derivative or change in omega m with respect to change in the time. So how to get these quantities? P we have already noted down, j is unknown, omega m and d omega m by dt can be calculated from the curve. So just draw a tangent at some flat portion of the curve and just extend this point on two axes. So this point, so here you will get omega m, and this distance is d omega m, and this distance is dt. So let's say this point omega m is 800. So d omega m will be 800. 800 minus 0 actually. 800 minus 0 divided by dt. Suppose it is some 2 seconds this point. So 2 minus 0. So this will be actually, these are just zeros, so 800 by 2. So value of d omega m by dt will be 800 by 2, that is 400. Okay, and omega m value is 800, like that. So you get these two values from the curve. Just rearrange the equation and we can write this equation for j. Unknown can be calculated. So in this way, using retardation test, we can determine its unit is kg meter square. Now uh, if it is suppose a disk of which you want to calculate J, and you know the mass of the disk, weight of the disk. Okay, let's say, because many times there is a flywheel mounted on the motor. Flywheel is just a disk, heavy disk, metal disk coupled to the motor, and this disk is having a radius. So this in case of disk, it is a radius of gyration, rho. So whatever is the radius of the disk, it is a radius of gyration. Otherwise, if it is somewhat like some different surface and rotating, then we have to calculate the radius of gyration by calculating some mean value or like that. So it is half rho square m. So inertia of the disk is half rho square m, where rho is a radius of gyration, m is mass of the disk. So in physics, you might have denoted inertia by I, but in electrical engineering, as I is already taken by current, so we denote inertia by J. So this is how J can be calculated, and it plays very important role in dynamics of the drive. So that's what about inertia.